Okay, so here's 3.6. This is about derivatives of log functions. The most important one is natural log. The derivative of natural log x is 1 over x. In case you have to find the derivative of a different logarithm, like log base 2 of x or log base 10 of x or whatever, this is the formula. So, yeah, let's just use that. So the first thing we're going to do is we're going to use that together with the chain rule. So so maybe I should write y equals on these. So then y prime would be, okay, so how do we do the chain rule? You do the derivative of the outside with the inside still in it. So the derivative of cosine is negative sine, and that's going to have the inside still in it. And then I multiply by the derivative of the inside, which we now know the derivative of natural log x is 1 over x. So that's it. We just had to use the chain rule and this formula that we just learned. Okay, let's do this one. This is also a chain rule, except now I have natural log on the outside. Let me, because I'm about to do a derivative, I don't like square roots, I like powers, so I'm going to write it that way. But, so y prime would be, okay, natural log is on the outside, so the derivative of natural log is 1 over the inside, so 1 over the inside. Times the derivative of the inside. So now I'm doing the derivative of, actually, I won't do this all in one step. I'm just going to write, this is the way I did it before. What I still have to do is I still have to do the derivative of this. If you get good, you can do this in all one step, but I don't want to do too much at once because I want everybody to follow me. So what I have going on inside here is just another little chain rule. So the outside function is the 1/2 power. So we know how to do the derivative of a power. I bring the power down, and then it's going to be this same number to the, I have to subtract 1 from the power. 1/2 minus 1 is negative 1/2. Then I multiply by the derivative of the inside. The derivative of the inside is just 2x. And I should remember to do the derivative of this, but the derivative of this is just 0. So I'll just write it like that. And then, yeah, I can cancel some 2's, but other than that, there's nothing to really cancel other than that, so maybe I'll just write my answer cleanly. Yeah. Next, let's do this. So yeah, I had to throw in one of them that has a logarithm of a different base, but this shouldn't scare us much. So quotient rule, bottom times the derivative of the top. I'm using this formula, so it's going to, the derivative of log base 2 of x is 1 over x natural log 2. So that's bottom times the derivative of the top, minus the top times the derivative of the bottom, over the bottom squared. Okay. So here's a thing you can do now. It's called logarithmic differentiation. I'm going to find the derivative of y for this y, which this looks like maybe a nightmare. This is something that we could do without any tricks. We could do this without logarithmic differentiation. It would just be a terrible mess. So I see the quotient rule. On the top, we would have to use the product rule, and we'd have to use the chain rule a couple of times. But logarithmic differentiation is going to help us a lot. So here's how you do logarithmic differentiation. First step is to do the natural log of both sides. And as I go, I'm going to simplify the natural log of this. And I'm going to use log rules. And then that's the point of using logarithmic differentiation. So if you remember, for log rules, if you have the log of a fraction, I can turn this into, let's see, the ones on the numerator are positive and the ones in the denominator are negative, and the powers can come down. So 4 natural log x squared minus 3 plus natural log x plus 1, and this doesn't have a number in the front because this is like the 1 power, so you can put a 1 here if you like, but that doesn't do anything. Minus, because now this is in the denominator, 2 natural log x minus 2. Okay. Now what we do the derivative of both sides, and this is like implicit differentiation now. So if we were doing implicit differentiation, what would be the derivative of ln y? Well, the derivative of natural log is 1 over the inside, and I have to multiply by the derivative of the inside, which is y prime. Right? Okay, so now let me do the derivative of this. So I've got a 4 times, okay, now I have a little chain rule, so it's 1 over the inside times the derivative of the inside, which would just be 2x. Now I have 1 over x plus 1 times the derivative of the inside, which is just 1. Now I would have a negative 2. The derivative of natural log x minus 2 would be 1 over x minus 2 times the derivative of the inside, which is 1. Okay. So y prime, I want to solve for y prime, which means I'm just multiplying by y. And let me clean this up a bit. 8x over x squared minus 3, 1 over x plus 1, 2 over x minus 2, like that. Now, one last thing. I want my answer to not have any y's in it. So in the end, I'm going to replace this y with the original y. So this y gets replaced with this, and then everything else I'm going to write is the same. And that's logarithmic differentiation. Let's do it again. Slightly different scenario. First step is to do the natural log of both sides. And keep in mind, actually maybe I won't do everything at once here. I can bring this power down. So I get natural log y equals x natural log x. Now I'm going to do the derivative of both sides. The derivative of ln y, and in fact, this step is always the same. On the left, you always have ln y, and then you get to do the derivative, and the derivative of ln y is always this. So it's just that again. And then here, I'm going to have the product rule. So 1 times natural log x plus x times the derivative of natural log, which is 1 over x. I guess those cancel, don't they? So I solve for y, or solve for y prime. So it's just y times this stuff. And then in the end, I replace y prime with what it is. So my final answer does not have any y's in it. Okay. Let's do one more. So I have x to the sine y equals y to the x squared. So what happens if I do natural log of both sides? I can take the powers down. Like that. Now I can do the derivative of both sides with respect to x. And again, this is like implicit differentiation. So when I do the derivative of sine y, I get cosine y times the derivative of the inside, which is y prime. So I'm doing the product rule. So I did the derivative of this, and then I left this one alone. Now let me do this the other way around. I'll leave sine y alone, and the derivative of ln x is 1 over x. Okay, and then that's going to equal the derivative of this side. So again, I have the product rule. So 2x ln y, because that's derivative of x squared is 2x, plus x squared times the derivative of ln y, which is 1 over y prime. Right? Now, this is like implicit differentiation. I have y prime here and here. And they're actually on opposite sides of the equation this time. So I'm going to do almost the same thing I always do. I'm going to move all the y primes to the left. Everything that doesn't have a y prime is going to move to the right. I'm going to factor y prime out of the left. So what's on the left? This was already on the left. I would also have this subtracted over to the left. And I won't write the y prime because I'm factoring out y prime. And that would equal what? Well, this was already on the right, and that's going to stay on the right. This has to move over to the right. So I'm there. And then finally, I can solve for y prime by just dividing by this stuff. All right.